how to make mathematics easier? How to make adding and subtracting, multiplying and dividing faster? How to do quick calculations in your head? Sorry, give me a few seconds. You might want to hold on. Did you know the Earth is about 4.5 billion years old? Or its diameter is around 8,000 miles? Or at the equator, it spins about 1,000 miles per hour?
Scroll, are you ready? 5, 4, 3, 2, 1, go!
All these amounts are estimates. They're not exact, but the amounts are close enough to the real answer and can be used to make quick calculations. Follow me and let's take a look at estimation.
Estimation. What does estimation mean? Well, it's the same thing as approximation. What does approximation mean? Well, it's like saying about or around. Something is around 40 meters tall, or something weighs about 50 pounds. They all mean the same thing. It's not the exact answer, but it's very, very close. And all of them make mathematics much, much easier. Let's take a look. Estimation is an answer that is close to the exact number. It's not perfect, but you don't always have to be perfect, especially when you're outside your math class. Estimation is really helpful to see what an exact answer should be about, and to do quick calculations. And this is great for predictions, samples, or making sure you're not getting some
crazy answer
when doing mathematics. We'll talk about that later, but right now, let's do an example. Here we have the number 97. It's a prime number, and it's kind of difficult, but it's really, really close to an easy number. If you think about it, it's between 90 and 100. And if you use a number line, you can better see which number is closer to. I'll also put 95 on the number line because it's in the middle. It's exactly between 90 and 100. Now I'll place the 97 on the number line, which shows us that 97 is closer to 100. It's actually 7 away from 90, but only 3 away from 100. So we can estimate 97 to 100, or 97 is about 100. And since 100 is a multiple of 10, it should be an easier number to remember and use.
Estimation is used all the time, and you probably use it more than you think.
You're right! The other day, a person asked me how far my school was from my house, and I thought about it. I don't know the exact distance, so I told them it is about 4 miles, and that's estimation. And there's so many more examples.
Estimation and approximation is all around you. It's used everywhere and anywhere. Come take a ride with me, and I'll show you some people who use estimation and approximation. Builders and engineers, doctors, the military, shoppers, the people who buy things, athletes and sports announcers, farmers, business professionals, train conductors, airline pilots, anyone who drives, flies, or sails. Those are only a few examples, and there's so many, many more. I showed you how to estimate. Now let's use estimation to make addition and subtraction easier. Now I know this is a simple addition problem, but this is just an example. Let's estimate. We got 63, which we want to change to an easier number. I think changing it to a multiple of 10 will help. You know, 10, 20, 30, 40. And 63 is between 60 and 70. We can draw a number line with 60 on one side and 70 on the other. We can place 65 on it too, because it's exactly in the middle. So where does 63 go on the number line? Here it goes, and as you can see, it is less than halfway and is closer to 60. So we can change 63 to 60. Now let's estimate 28. 28 is between 20 and 30. But let's not draw a number line. Try and picture one in your head. Oh, 20, 30, 25 in the middle. And 28 is greater than 25, so it is closer to 30. Change 28 to 30. Now we can quickly add. 30 plus 60 equals 90. Check this out. If we add the actual numbers, 63 plus 28, we get 91. So our estimate is really close to the actual answer. Let's try one more. So let's do this. Add 8 plus 5 plus 3 equals 16. Carry the 1. 1 plus 5 plus 1 plus 2 equals 9. And 4 plus 1 equals 5, which gives us 596. Now estimate it, and we get 600. Stop! The key to estimation is to estimate before you solve the problem. Remember, estimation is supposed to make your life easier, not give you more work to do.
Let's try this problem again. The thing with estimation and approximation is that you can be flexible.
He can swing. He can stretch. He can fly. He can bounce. And he can even dance.
That's not what I mean. What I mean is that you can decide how exact you want to be. Check this out. Here is 432. If we want to be fairly exact, we can estimate it to the tens place, which would be between 430 and 440. And as you can see, it's closer to 430. But what if we were dealing with larger numbers, like 10 million, and I gave you 432 to estimate? Well, I don't think 10 is that big of a deal, when the other numbers are in the millions. So we could be less accurate, maybe estimate it to hundreds, or maybe even thousands. Let's do thousands, because I feel that would be much easier. So 432 is between 0 and 1,000. 500 is in the middle, and 432 is less than 500, so it is closer to 0. Finished! Here are the 3 ways you could estimate 432. 432 could be estimated to 430, 432 could be estimated to 400, 432 could even be estimated to 0. None of these are the wrong or right answer. It matters how exact you want to be, or how big or small the other numbers are in the group. See, you can be flexible with estimation or approximation. It's about how big or small or exact you want to be.
Dr. Veeder loves to take his rocket for a ride after work. Last week's distances are below. Monday he flew 4,732 kilometers, Tuesday 9,457 kilometers, Wednesday 3,326, Thursday 6,599, and Friday 9,721. Estimate the total distance he flew during those 5 days, and then calculate the exact amount. Since all the numbers are in thousands, let's estimate them to thousands. 4,732 is about 5,000. 9,457 is closer to 9,000. 3,326 is approximately 3,000. And 6,599 is greater than 6,500, so is closer to 7,000. And if we estimate 9,721, it's about 10,000. Now we can quickly add them up. 5 plus 9 equals 14, plus 3 equals 17, plus 7 equals 24, plus 10 equals 34. So we have an estimate of 34,000. Now, let's find the exact answer. 2 plus 7 plus 6 plus 9 plus 1 equals 25. Carry the 2. 2 plus 3 plus 5 plus 2 plus 9 plus 2 equals 23. Carry the 2. 2 plus 7 plus 4 plus 3 plus 5 plus 7 equals 28. Carry the 2. And 2 plus 4 plus 9 plus 3 plus 6 plus 9 equals 33. So we get 33,835 kilometers. So our estimate is actually really close to the actual answer. 33,835 and 34,000. So our estimate is only 165 kilometers off, which is not that much since we're talking thousands of kilometers.
Doctor, how long does she have to stay?
Approximately 3 days.
That's an estimate, right?
Yes. It's not exact.
So, do you see how estimation can help you add and subtract? It makes it easier. Now, let's take a look at a few examples with multiplication and division, and see how it makes life easier. Estimation, approximation, about. They're all the same.
When you're using estimation to multiply and divide, you definitely have to be more flexible. Sometimes you might have to estimate one number to the tens place value and the other number to the hundreds place value. Or maybe one of the numbers is to the hundreds place value and the other one might be to the 10,000s place value. And when it comes to division, the estimates are not always perfect, and sometimes it takes a little thought and good old mathematics to find a good estimate. Remember, you don't have to be exact. You just want something close enough and quickly. So don't worry too much if you're not estimating both the numbers to the same place value. Let me show you what I mean. We have 236 divided by 5, and we want to estimate it. Cover up all the digits in the dividend, the inside, except for the first digit. Ask yourself, can 5 go into 2? No. Uncover the next digit and ask yourself the same question. Can 5 go into 23? Yes. Do not uncover any more digits, but instead find the number that is closest to 23 that 5 can go into. 23 is between 20 and 25, which are divisible by 5. In other words, 5 goes into both of them. 5 times 4 is 20, and 5 times 5 is 25. 23 is 3 away from 20, but only 2 away from 25, so it is closer to 25. Change 23 to 25. Now this is easy, but wait a second. We cannot forget about the 6, but we still want this to be easy, so just change the 6 to 0. Now we're ready to estimate, so let's do it. 5 goes into 25 5 times, because 5 times 5 is 25. Now since 5 cannot go into 0, just bring it straight up. So we're done. 5 goes into 236 approximately 50 times. Now this is only an estimate, but this is a great technique for checking if our real answer looks correct or is way off. And soon, or maybe even now, you can do this in your head. Unlike the equal sign, there's a few ways to show approximation, but the one I see the most looks like this. This is one of the better ways to show estimation because it's similar to the equal sign. The equal sign has 2 straight lines, and estimation, or approximation, has 2 curvy lines. So I think it's easier to remember.
Welcome to Mocha Mocha Middle School, where the kids love to come and learn, and are very, very well behaved. They even enjoy spending time at school. Okay, anyway, let's do an example. At Mocha Mocha Middle School, there are 33 students in a classroom. If there are 39 classrooms, approximately how many students does Mocha Mocha have? So, this is a multiplication problem that looks like this. 39 times 33. But since we only need an estimate, we can change 33 to 30. And 39 to 40. So now our problem looks like this. So now we have 40 times 30, and we can solve this very, very quickly. 4 times 3 is 12, and we have 2 zeros, so just place 2 zeros after the 12, and we get 1,200. Remember, this is only an estimate, but see how fast this was thanks to estimation.
Wow, I'm so lost. Great, there's some sheep. Maybe they can help me. Excuse me, how far is the nearest town?
Hey, Papa, this guy is lost.
Buh. It's approximately 20 kilometers that way. Buh. But remember, this is only an estimate. Buh. Let me get out of your way.
Jake has 436,764 marbles
Dude, that's a lot of marbles.
and wants to give them away to his 68 friends.
Dude, that's a lot of friends.
His buddy Spike
That's me.
told Jake that each person should get around 6,500 marbles each. He told him it is only an estimate, but pretty close to the actual answer.
That's totally correct.
But Jake isn't sure if Spike is the best guy to trust in these mathematical calculations.
Bummer, dude.
He wants a second opinion and asked us to see if Spike's approximation was a good one or not.
Sounds like a cool thing to do.
He has 436,764 marbles, and he wants to give them to his 68 friends, which means it'll be a division problem, and it'll look like this. The first thing we want to do is estimate the divisor, the outside number. 68 is between 60 and 70, but much closer to 70, so we'll change it to 70. Now let's look at the dividend, the inside number. Think simple. Cover up all the digits except the 4, but 70 cannot go into 4, so uncover another digit. Now we have 43, but again, it is too small, so uncover another one. And now we have 436, which 70 goes into. If we quickly list the multiples of 70, 70, 140, 210, 280, 350, 420, 490, we see that 436 is between 420 and 490. But it's closer to 420, so change it to 420, and 70 goes into it 6 times, so place a 6 here. We can quickly change the 7, 6, and 4 to zeros, and we're done. So our estimate is 6,000, and Spike's was 6,500, which means we're close. But let's calculate the exact answer to make sure Spike is correct. So the exact answer is 6,423. Spike's estimate was 6,500, and ours was 6,000. Wow, Spike was so close.
I told you, dude!
In everyday life, you probably do not need the exact answer all the time. Do you really need to know the exact number of cars on this street? How many people are racing down this hill? How big is this wave? How many people are at this concert? All these questions could probably be answered with a quick estimate. You don't always have to be exact. An estimation saves us time and effort.
You might have heard of the word rounding before.
I've heard of that.
No, not that kind of rounding.
Is it this?
The wheels on the bus go round and round, round and round, round and round.
No.
How about?
No. Stop. I mean the kind of rounding when someone asks you to round a number to a specific place value. It's the same as estimation and approximation, but it's more specific.
Wow.
Let's do an example. Let's round this number, 567, to the nearest tens place. But before we start, we need to understand place value. If we use a place value chart, we can see where the tens place is. But you should be able to do this without using a chart. So the tens place is here. We should know 567 is between 560 and 570, which are already estimated to the tens place. But which number is it closer to? Based on our knowledge of estimation, we can see it is closer to 570. So 567 rounded to the nearest tens place would be 570. So rounding is just a different version of estimation and approximation, except it's less flexible because you have to estimate to a specific place value. You know, like ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and so on and so on. But to be honest with you, it's not used that much in the real world, except when it comes to decimals and fractions and rounding things to the nearest whole number, especially when it comes to money. Again, money's decimals. I mean, you're not going to walk around and say, I have $200.05. You're just going to say, you have $200. Holy smokes, a penny! I'm sitting by this gorge in Sylvania that was made a long time ago by this river that carved its way through some limestone. And I'm wondering how deep it is. Well, I could pull out my tape measure, jump down here, and measure it. Instead, I'm going to use estimation. And I say, it's about 50 feet deep, or approximately 50 feet. See? Estimation. It makes our life easier. Estimating decimals is the same thing as estimating whole numbers. The only difference is there's a decimal. You can estimate to the tenths value or the hundreds, but usually you do not want to go less than that because the amounts are very small. Most of the time, you want to estimate to the nearest whole number. Let's do a couple examples. Today, I need to buy ketchup, mustard, and steak sauce. Let's go to the grocery store. The ketchup is $1.19. The mustard is $2.29. And the steak sauce is $3.89. Oh, wait a second. I just realized I only have $6. I need to figure out if I have enough money. But instead of calculating the exact amounts, I can do a quick estimate in my head. Let me show you what I mean. So, the ketchup is $1.19, the mustard is $2.29, and the steak sauce is $3.89. But why waste time adding exact amounts when I can do a quick estimate? $1.19 is about $1, $2.29 is approximately $2, $3.89 is about $4. By the way, if you did not know, the reason I changed $1.19 to $1 is because it's between $1 and $2. But it's only 19 cents away from $1 and 81 cents away from $2. So it's closer to $1. And $2.29 is between $2 and $3. But if you look closely, it's closer to $2. And $3.89 is between $3 and $4. But it's closer to $4 because $3.89 is 89 cents away from $3, but only 11 cents away from $4. So it's closer to $4. Now quickly add it up. 1 plus 2 plus 4 equals 7. Rats! I don't have enough money.
Estimation is very helpful when it comes to fractions and decimals, because remember, fractions and decimals are not even whole numbers. They're just pieces, and usually the amounts are so immaterial they're not important. For example, 65 and 1/12 can be estimated to 65, or 112 and 85 hundredths is approximately 113. And whole numbers are much easier to work with.
Farmer John wants to build a new fence around his house. He knows his yard is exactly 39 7/8 yards by 31 1/5 yards. He already has the post, but needs to buy wood for the sides. He wants 2 pieces of wood connecting each post so the fence will look like this. Estimate how many yards of wood he will need to buy to complete the entire fence. Okay, so let's take a look at this problem. Here's his house, and he wants to build a fence around it. So that's the perimeter. You know, perimeter, the distance around the outside. He knows how long the sides are. One is 39 7/8, and the other is 31 1/5, which tells us this side is also 39 7/8, and this side is 31 1/5, because they're across from each other. But the problem tells us not to use the difficult numbers. It tells us to estimate, which should be a lot easier, because who wants to figure out 39 7/8 and 31 1/5?
Me, let me do it, I'll do it. Ooh la la, that's crazy.
So let's estimate. We have 39 7/8. Let's round it to the nearest whole number. If you think about it, 39 7/8 is between 39 and 40. We can draw a quick number line and separate 39 and 40 into 8 pieces. Then place 7/8 in the correct spot to show it's closer to 40. So 39 7/8 is approximately 40. Now let's take a look at 31 1/5. But instead of drawing a number line, we can just look at the mixed number. We know 31 1/5 is between 31 and 32. But which one is it closer to?
That's the question.
An easy way to figure this out is to see if the fraction is less than or more than 1/2. And to do this, we can just cut the denominator, the bottom number,
The denominator.
in half. So what is half of 5? 2.5. because 2.5 plus 2.5 equals 5. And since we had 1/5, 1 is less than 2.5, so we know 31 and 1/5 is closer to 31. Now we have 40 and 31 as our numbers, and if we use them to calculate the perimeter, we get 40 plus 31 plus 40 plus 31, or 40 plus 40 plus 31 plus 31. 40 plus 40 equals 80, 31 plus 31 equals 62, and 80 plus 62 equals 142. Finished, right? But hold on. Farmer John wants 2 pieces per post, so we need twice as much wood. So 142 plus 142 equals 284. So he needs at least 284 yards of wood to complete his fence. 284 yards. And Matt, we solved using estimation.
Did you know the longest road tunnel in the world is located in Laerdal, Norway?
We've been there.
Really?
Yeah. It's really long, but it's cool.
It's approximately 25 kilometers long, or 15 miles.
Wait a second. I heard it's 24.5 kilometers long.
Yes, but 25 kilometers is only an estimate.
Oh, but why did you change 24.5 to 25? Why not 24? It's exactly in the middle.
That's correct. But usually, when it's exactly in the middle, like 45 or 24.5, you normally round up. So 45 would be 50, and 24.5 would be 25.
But what if you have more than one number? Like 25, 95, 55, and 75.
Well, since you have more than one, it's better to alternate up and down. What I mean is, 25 would be 30, but 95 would be 90, and 55 would be 60, but 75 would be 70. You see how I went up and down, up and down? That way, you even out your estimating. But if there is only one, you always round up.
Oh, I see. That makes perfect sense.
Now they do. They got a linebacker on it. Young comes out of there. Still on his feet is Steve Young. And Steve Young still going. Young cuts back. Young touchdown.
That's approximately 4 guys who missed him, and he just ran through about 5 guys. He ran approximately 60 yards for a touchdown. Now that is only an estimate, but did you see that run? Did you see that run? Are you kidding me? Are you kidding me? Touchdown! Touchdown!
Did you know there is a form of estimation where people use a small group and then estimate their results for a much larger group? So instead of asking everyone in the group, they only ask a few, but still claim the results are for the entire group. This kind of estimation is called sampling.
Sampling is the process of selecting a smaller group from a larger population, so that by studying the smaller group or sample, we can make an estimate about the larger population. Do you get it?
Huh?
sample is a smaller group of a larger set of people or things. In the real world, people are constantly using samples to answer important questions or determine information. Let me show you what I mean. The other day, I was told that more people in the world like chocolate ice cream. Well, no one asked me. A matter of fact, my favorite ice cream is strawberry. Did anyone ask you? See, it's impossible for them to ask every single person in the real world what their favorite ice cream is. There's no way they could do that. Let me show you what they do. Here is a very large group of people, and instead of asking every single person what their favorite kind of ice cream is, they might only ask this guy here, and maybe this girl over here, and this guy here, and this girl here, and this guy, and this girl, and then they take their answers and use them for the entire group. So they're really only estimating because they're only asking a sample of the group what their favorite ice cream is, rather than asking everyone.
You grabbed all the free samples again, didn't you?
Of course. Why buy the entire cake when a sample is just as good?
There are 4,000 houses in the town of Gabberville. The local government wants to know how many of them have computers, so they asked 100 households whether or not they have a computer. 80 of them said yes, 20 said no. Based on this information, approximately how many of the 4,000 households in Gabberville have computers? So we know they did not ask all 4,000 households. They only asked 100, which means they took a sample. And the question is asking approximately how many of the 4,000 households in Gabberville have computers. So we need to use the sample information to calculate how many of them have computers. Let's take a look. The question only asks how many of the households have computers. So all we care about is the 80 that said yes. And since they asked a total of 100 people, we make a fraction 80 over 100, or 80 out of 100 said yes. And then we use the 4,000 to calculate approximately how many households in all of Gabberville have a computer. So the problem will look like this. Do you see that the 100 and 4,000 are on the bottom? They are the denominators because they are the total. So we know 80 out of 100 have computers, and all we need to do is find out how many out of 4,000 have computers. And I think the easiest way to solve this is to ask ourselves, how does 100 change to 4,000? Well, we have to multiply it by 40. 100 times 40 equals 4,000, which means we need to multiply 80 by 40, because whatever we do to the bottom, we need to do to the top. Or, the mathematical way, whatever we do to the denominator, we need to do to the numerator. And 80 times 40 is 3,200. So, 3,200 households have computers. But remember, this is only an estimate based on our sample. Now people in the real world use this kind of sampling all the time.
You know, more dentists recommend Crest than all other toothpastes combined.
As you can see, it really does make our life easier. I mean, imagine going door to door and asking 4,000 households whether or not they have a computer.
Yes? Hello there. I was wondering if you had a moment to answer one simple question. No.
What do you want?
Hello there. I was wondering.
No.
Yes.
All they did is ask 100 households. Sampling is just like estimation and approximation. It saves us time and makes our life easier.
Midpoints.
Well, I hope this will help. And remember, math is everywhere and anywhere. Math is math. It's supposed to be fun. See you next time.